Good afternoon, and welcome to yet another episode of the Angry Astronaut, a very special episode, and I tend to say that quite a lot, but this time I really mean it. We have an opportunity to interview some individuals, or rather a very key individual, who is going to be responsible for the construction, the deployment, and the ongoing operation of the first commercial space station in human history. His name is Christian Maender. He serves as the Director of In-Space Manufacturing and Research at Axiom Space. He has over 18 years of human spaceflight experience with key leadership roles, and he's implemented a number of microgravity research and technology demonstrations at the International Space Station. On top of that, he's the recipient of numerous awards, including the NASA Outstanding Leadership Medal. He earned his Bachelor's of Science and Master's of Science in Biomedical Engineering from Tulane University, and I think we're in for a very interesting conversation. Thank you, Mr. Maender, for joining us.
Thank you for that warm introduction. I'm glad to be here.
All right. Well, the first question that I'm going to ask is, what makes Axiom Space stand out? You've got people like NanoRacks, you've got behemoths like Blue Origin, you have other organizations like the Gateway Foundation, all of whom are talking about commercial space stations. What is going to make your station special and, perhaps the first one to be deployed successfully?
Well, I think what makes Axiom Space unique is this combination of a really deep bench of experience in human spaceflight, coupled with the practicality that we bring to the equation in terms of what it really takes to build a space station. There are, and motivationally so, lots of interested parties in building infrastructure in orbit and certainly building different kinds of destinations, but those that are in the know appreciate that it's not an easy endeavor, and that it does take time and it does take experience, and our team brings to the table literally hundreds of years of human spaceflight experience, and certainly massive amounts of experience from the ISS program, and so we are in a really unique position to leverage all that we've learned when we built the International Space Station, and come at it from a commercial angle and say, hey, we understand the critical pieces of this infrastructure, this construction that requires some real safety attention, some real attention to detail, and then we understand where we can, perhaps approach this from a different angle, more cost-effective construction approaches that still meet the same intent. I think what also sets us apart is, in some ways, the way we're approaching the market. Space is just, and low Earth orbit, there's so much potential in microgravity, but there's so much potential for so many things, right? We can certainly fly people to orbit, and that is an important from a platform of offering and leveraging an even different set of services beyond that. Now, certainly we'll accommodate and fly crew to orbit, whether those be private visitors or more excitedly, a growing complement of professional astronauts from countries all over the world that are doing meaningful work in space. But it's the meaningful work that's really exciting. It's the research opportunities. It's the in-space manufacturing potential. It's the demonstrations for exploration systems that need to go beyond low Earth orbit. It's leveraging the platform as a base to offer all sorts of low Earth orbit services and satellite servicing and fueling and all of these things that are going to be needed in an infrastructure layer that you really need to sustain a constant and sustainable human presence off the planet. And so, we're approaching these markets holistically and building a platform that really addresses all of those needs, with the idea that over time we will have the ability to differentiate into bespoke infrastructure that ultimately, someday for us strategically and visionary, leads to cities in space.
Okay, well, you just said cities in space, which is going to get my viewers extremely excited. So that being the case, can you give us an idea? I was briefly told about a 50-year plan. Can you give us a brief overview of said plan?
Well, the 50-year 5-year plan, when you really look at what we can do as a company, we look at what we're building with Axiom Station, this first platform that we're building, as we call it, the cornerstone for an infrastructure layer in low Earth orbit. And the cornerstone analogy is key here, is because you have to start putting in place infrastructure that aligns with market growth. And I think one of the things that's compelling to us is that, or at least important to us, is that it's not just about building a space station. You have to go build the markets that are going to use it as well. And so as much energy as we're putting into the platform, we're putting equal energy, and it's in particular where I spend my time focused, is building the ecosystem that drives the infrastructure needs that need to be in orbit. But where we see tremendous promise is in in-space manufacturing and industrialized research applications in orbit. When you look at microgravity as an innovation platform, when you understand that when you take gravity out of the equation, how that fundamentally changes physical forces and how they behave in both biological and physical systems, you start to think about microgravity in space in general as somewhat like the internet was 25 years ago. It's this new construct that enables all sorts of creative new economic activity that couldn't have been envisioned when it was created in the first place. And microgravity in some ways is like that for us, because as traditional industries start to realize what it means to take gravity out of their processes and out of the way that they think about how they need to do research and manufacturing, they're going to find a whole host of applications that can be done off the planet. And then when you couple that with the economics of decreasing launch costs, both from the fact that there's a proliferation of launchers coming to market, and also a proliferation of greater needs to fly to orbit, driving costs down, you start to open up all sorts of business cases that make commerce in low Earth orbit possible. And when you drive commerce to space, you drive people to space. And so for us, the 50-year vision is building both the marketplace and building the infrastructure layer by layer that ultimately yields the presence of hundreds, not thousands of people off the planet. And where we want to be is at that intersection of markets and intersection of infrastructure, providing the backbone of services that are needed off the planet to sustain human population. And the thing that's visionary about that, it certainly is important for us because we think that there's so many ways that space can improve humanity, but equally important is just the infrastructure layer that we put out there in low Earth orbit ultimately provides a really stable platform for moving humanity further off the planet. If you have hundreds of people working and living in space, you have an economy set up to do that. You also set up possibilities for exploration, architectures, and missions that no longer have to leave the planet's surface, and they can leave from low Earth orbit. And from that regard, you really set up a sustainable supply chain to and from more distant destinations, and you really start to open the aperture, so to speak, on humanity living in a greater swath of the solar system.
Now, thank you for that. One of the hip things that people talk about a lot these days is artificial gravity. That artificial gravity is going to be an absolute necessity for mankind because of bone degradation, muscle loss, that sort of thing, and the agony that it puts astronauts through when they return, especially after a long stay. But what tends to be forgotten is the importance of microgravity to medical research, to manufacturing. Can you give us some examples of things that can only be done in microgravity?
Oh, sure. I can give you some examples of things that have come out of research on the space station. When you take gravity away, you take away things like sedimentation, the behavior of different weighted particles in a solution to settle to the bottom of a container. Imagine a bubble tea, so to speak, and you get the tapioca bubbles at the bottom of your cup. It changes buoyancy and convection. There's no buoyancy in space. There's no convection in a traditional sense, and so you you change the way heat transfer works in space, and so you can get much more controlled thermal processes if you want those in space. You can enable things like containerless processing, where you can levitate materials, eliminating the effects of the container that they're in, and that has all sorts of applications for new materials that you can potentially create that are potentially refractory or reactionary to the containers that they would normally go in and on Earth. And hydrostatic pressure, for example, is no longer relevant. Surface tension becomes a dominant force, and so you can use that to drive fluids and move fluids without pumps, for example, simply through capillary action. And so there's lots of different physics that you can play with, but what's really fantastic is how it affects both biological and physical systems. Some of the early discoveries that are coming out of space station in biology, for example, are stem cells behave interestingly different in space, and there's some early evidence that they maintain, quote unquote, their stemminess longer. You can imagine if you can maintain a eternal pluripotent line of stem cells in orbit, or more importantly, or maybe even more attractively, you can fly individual person stem cells to orbit and maintain a cell bank, so to speak, where you can derive therapies and treatments for that patient when they get sick on the ground, and bring those back to treat that patient. There's some really compelling opportunities in that sphere in and around individualized medicine. You can grow cells in a more biologically and physiologically relevant three-dimensional structures in space. And you imagine growing cells on a petri dish in gravity, they spread out in a 2D layer, but in space they can grow into the three-dimensional structures that they tend to do in the body. And then that provides all sorts of interesting opportunities for things like tissue on a chip, lab on a chip systems, the ability to perhaps fly your cancer cells to orbit and grow them in a biologically relevant way to assess which cocktail of medications is going to be most effective on those cells, and immediately transfer that data to ground for treatment in the hospital. So those are just a couple interesting places. 3D bioprinting in the same idea, in the same vein there, is also really attractive, because in gravity you try to print complex three-dimensional tissues and they turn into soggy puddles on the bottom of the printer. In microgravity, you can print these structures with vasculature and different layers of kinds of tissue and cells, and then you can let them mature in a gravity-free environment, and then you can bring those home and use those as implants, ultimately maybe even yielding full organs that you can bring home for transplant. And on the material side, when you take away sedimentation and convection, you can fundamentally change the way things like metal alloying, processing of crystalline structures happens. The thing that's talked about often in manufacturing in space circles that has gotten the most attention in years is Z-bland fibers, which is an exotic glass fiber optic, heavily doped with heavy metal ions. And the problem is that in gravity, all of those heavy particles separate out, and you don't get an even distribution of those different molecules across the glass composition. But in microgravity, as you pull it, you get a much cleaner fiber, which performs in some ways incredibly 100 times better in many measurements than the best fiber you can pull on the ground. And so things that you can do with that, you can create fiber lasers, you can create fiber scalpels for medical manufacturing devices, and as you get the ability to pull even longer fibers, you can talk about really revolutionizing cloud farms on the ground or even in space, because you can create fiber that transmits so much more data over short distances. There's some really neat applications coming out of space station in retinal implants. Layer by layer deposition in space has proven to allow a company called Lambda Vision to create a retinal implant that has a protein that responds to light and sends signals to other cells in the retina. And by layering that protein in an even distribution in microgravity across a polymer, you can create a retinal implant that hypothetically is much, much simpler to install in the eye or surgically put into the eye as opposed to today's treatments, but can improve diseases like retinitis pigmentosa, where you basically are bringing sight back to the blind. I mean, and when you look at it from that perspective, really restoring vision to someone who has lost their ability to see, that's where I get super excited about the potential, because if we've already found that application in microgravity, think about how many more we're going to find.
Yeah, that's astonishing and exciting stuff, and something I expected you to talk a lot about. Very, very inspiring. A little off topic, there are a number of questions that I've my supporters have asked me to question you about. First of all, are you privy to any information in terms of Axiom's choice of launch vehicles to get the station modules up there, and also connected to that, what sort of spacecraft do you intend to use to ferry astronauts back and forth to this station? The Crew Dragon, or the Starliner, or perhaps the Dream Chaser if it becomes human rated, that sort of thing. Any information about that?
What I can say is that both for the launch of our modules and the launch of our crews, we are vendor agnostic, in the sense that we're setting up a platform that can be essentially launched on a variety of rockets and be serviced by a variety of spacecraft. And so from that regard, we're doing that obviously for a couple of reasons, right? It enables competition. It provides redundancy for any kind of bad day on Earth, and where maybe one provider is down for some period of time because of an incident or an accident. But it also helps drive, from our perspective, it helps drive costs down because there's competition. I think as we evolve in this space, pardon the pun, what I'm expecting is a greater proliferation of cargo vehicles and cargo opportunities to orbit. Some that Axiom may even look into at some point. And also, I expect over time we're going to see more players in the putting humans in orbit space. I mean, even the recent announcement around Rocket Lab's intention to go public through a SPAC implies that they're going to be building a bigger rocket that they're planning on human rating, which implies that maybe they have some ambitions on flying people as well.
All right.
So we will probably work with any vendor out there.
Excellent. Well, that's good to know. I'm sure that SpaceX, ULA, and everybody else will be happy to hear that. And so how do you see, this is a question from one of my supporters, how do you see Axiom fitting into a beyond Earth exploration campaign, such as near Earth resources, lunar development, Mars, and beyond? Are you designing specific capabilities to support that? And connected to that, I'm curious also, do you have any ambitions as far as fuel depots are concerned, something that's near and dear to my heart?
Well, the way I would answer it is this: we are an infrastructure in the space company, and so when it comes to moving human presence off the planet, we want to be in any place there's humans off the planet. And so from that regard, I would tell you that the designs that we're putting into our space station today are in some ways translatable to space stations we can put other places, or habitats that we can put on surfaces in the future. And so where we go will be obviously of strategic and economic importance, and we'll have to look at all of the relevant market factors along the way to see how we do that. I think our early focus, our tactical focus, really is about enabling this LEO infrastructure, because we believe heavily that without it, you really don't have a sustainable supply chain that supports exploration further out. And so speaking to that supply chain, I think that's probably one of the most attractive things about what we're doing, is that when you put a large platform like Axiom Station in orbit, you have to keep it supplied with all the things you need to keep a crew happy and healthy, and all the things that you need to do to continue the research and manufacturing. That enables some of the cost efficiencies in getting things potentially to orbit, which also could potentially enable opportunities to serve as a fuel depot for various architectures, but also enable those technologies that are ultimately needed to be tested and the TRL raised on them. So we can do that on our platform, and then we can enable new providers to put fuel depots in various places further out if necessary as well. Or maybe we'll do it ourselves. Don't know.
Thank you. Will microgravity engineering, this is from another supporter, be used to provide passenger comfort in initial design concepts?
Provide passenger what?
Comfort.
I'm not sure if I know how to answer that, but maybe this isn't the right way to answer it, and you can stop me if it is, and I just had this conversation this morning, we're not just building another International Space Station. This is a platform that is going to be, in some ways, transformational in terms of the human experience in space as well. We brought in Philippe Stark early on in the process, for example, to design a crew quarters that was, both in some ways luxurious, but also comfortable. And we have a lot of discussions, not around the engineering that needs to happen, but the design that needs to happen, creating interfaces in space that are both human and designed for space. And so from that regard, to the extent that we can, we want to humanize the experience in space. And that's not just for the visitor, or it's not just for the astronaut. It's about creating good human factors and good human interfaces for the lab technician that needs to work in orbit, or the factory floor, good ergonomics for the factory floor in space.
Gotcha. Another question. Could this space station, or a twin one, and this is kind of based on the idea of using a string of modules like a train, essentially, with a conventional or a nuclear thermal engine on the back, something like that. Could it be used as an interplanetary ship?
I don't know if I'm in a place to answer that, but what I would tell you is that we do want to create architectures, if we can, that support testing of alternate transportation means, alternate fuel, alternate propulsive technologies. There's only so much that you can do in that arena, maybe around a human-rated spacecraft, but we're also seeking to provide capabilities when we need to, where we can do remote ops away from the space station to test some of these things. I don't know if that answers your question, but
It does. And a lot of these things are way in the future, far beyond the scope of what you guys have planned. And I've talked extensively about, your plan of introducing one module after another attached to the ISS, and then eventually making it a free-flying station, which is, a wonderfully unique solution and makes it that much more doable. A question from another channel, a partner of mine, called To the Future. Does Axiom have any future plans to use Bigelow, or I guess Sierra Nevada is using these two style inflatable habitats?
What I would tell you is the architecture we're investing in initially is on purpose, and it's purposeful in the sense that because we're an early partner with NASA in this endeavor and we're attaching ourselves to the ISS, we chose an architecture familiar to the agencies that are on the ISS and are very compatible with the ISS, and that's why you see these traditional designs around, aluminum pressure hulls, just like the ISS modules. But what I can tell you confidently is that we're not limiting our design space to, aluminum pressure vessels. That I think in the future of our infrastructure that we provide as a company, you'll see a spectrum of opportunities, including inflatables and even more futuristic things that I can't really talk about yet.
Now, there has been some talk of you guys putting up a station around the moon sometime in the future, perhaps supplementing the Lunar Gateway, perhaps serving an entirely different purpose. This question is from a nuclear physics specialist. He works through a power plant, actually, and is into radiation protection. Do you have plans of experimenting with various types of radiation protection methods for the astronauts, especially on this lunar station, if you do build it, that is, of course, going to be exposed to a lot more radiation and cosmic rays?
What I can tell you is we've already talked to a number of potential customers about using our Axiom Station as a means to test those technologies that are needed once you get outside the Van Allen belts. And so in that regard, we can provide some capability to do that. The radiation environment in low Earth orbit is pretty benign compared to when you get further out. If we go to putting space stations around the moon, we go there because there's economies to be serviced in that regard. We're very attracted to and interested in situ resource utilization as that matures, and we're also interested in using our Axiom station today as a means to test and raise TRL and those kind of technologies that are needed to support lifting resources off the moon in the future. And so I think as those capabilities come online, you'll see our interest turn to the moon. And then in that regard, we will invest ahead of that the research necessary to ensure that we have the radiation shielding capabilities, that are required to keep our human occupants healthy along the way.
My last major question, although more may come to mind, but I know you have a limited amount of time, is one that I wasn't sure whether you'd be willing to make a statement on, and that is the viability of the Gateway Foundation and the whole Voyager concept. Stories are circulating all over the place now that they're going to start creating a rotating space station, this mammoth thing, by 2025. What statement might you have about the viability of such a thing?
What I would say about these kinds of things, what I take out of all of these ideas is I'm encouraged by the fact that so many interested parties want to build capabilities in orbit. I can only really speak to, or I'm only willing to speak to what I know Axiom knows to be true, that you need to have a significant level of expertise in order to build spacecraft that are safe and can keep humans safe in orbit, and that building those spacecraft take time, and they certainly take a reasonable amount of funding and capital to go do. And I know that our team's equipped to do that, and I hope someday that spacecraft like that can exist, but this is my personal perspective. I think that what they strive to do is very ambitious, and Axiom knows what's realistic.
Right. I went and lied. There was actually one other question. You're going to be training astronauts. You have your own training program and that sort of thing. But some of the people who come up to your station may not be, the same cream of the crop, the extensively psychiatrically trained or researched people that NASA astronauts are. Do you have anything in place in case there are any incidents, or if somebody comes up just because they want, say, a hotel room and they're willing to pay the money, do you have something in place to keep these individuals separated from the very important work that you're doing?
Well, I can't speak to the separation. I mean, at first, we're going to do the best that we can to ensure that the hotel, we don't like to use the word hotel, but to use that the accommodations for our private visitors are comfortable and allow them to experience space they want to. Anecdotally, I'll tell you that all the potential customers that we're talking to are not interested in a tourist experience in space. They're interested in what I would call more of an eco-adventure experience, where they're up there to do meaningful things for meaningful causes that they care about. But that said, we're going to be doing our best from a design perspective to keep the, so to speak, the factory floor separate from the berthing accommodations. Now, that said, I think at the end of the day, I really think, for us, our focus as a company isn't on flying people on to space to just go to space. Our focus is flying people in space with purposeful ambitions for growing the low Earth orbit economy, and that's the kind of customer that we hope to find.
Wonderful. Is there anything you would care to add?
No, just that we love your show and
thank you,
and love your channel, and we are glad to be a part of the continuing story in commercial space, and hope to be a feature story now and into the future.
Well, thank you so much for the time you've given me today. This has been fantastic. As I say, I wish I had more time, but I know you're a busy guy, so I'm going to go ahead and cut things off at this point. Once again, really appreciate the time and the effort you made today to speak to me, and looking forward to seeing your dream take shape.
Well, thank you, and we appreciate you helping tell the story.
All right. Well, you have a wonderful day.
Take care.
Bye-bye. And so that's it, ladies and gentlemen. I feel that these folks have the most realistic chance of creating the first commercial space station. There is so much NASA expertise here, and they have a really solid plan that's very doable, and I can't wait to see what they create. So if you want more information about what happens or what these folks are doing, I have them linked in the description. And as always, until we have a truly commercial station in orbit, creating things that can only be created in space for the good of humanity, I urge all of you to stay angry about space.